What if we took our calm, orderly solar system and flipped it upside down? For billions of years, the planets have stayed in their neatly arranged orbits. But today we're shaking that cosmic snow globe. What would happen if Jupiter sat right next to the Sun? What if Earth traded places with Mars? And what would our solar system look like if we rearranged all the planets by size, from biggest to smallest, and then reversed them from smallest to biggest? Would Earth survive this extreme makeover? Or would we need to find a new place to live? Welcome to What If. The solar system gets reorganized. Let's start by lining the planets up from biggest to smallest with the Sun at the front. And right away, we hit a huge problem. But before that, let's explore how each world transforms in this new order. Jupiter, the heavyweight champion of our system, moves all the way inward to Mercury's orbit. This places it just a fraction of its original distance from the Sun. Crazy? Actually, astronomers see this all the time. Many stars have hot Jupiters, giant gas planets roasting right beside them. With its new orbit, Jupiter's year shrinks from 12 Earth years to just 3 months. Temperatures soar past 160 degrees Celsius (320 degrees Fahrenheit), causing Jupiter's upper atmosphere to expand and boil. What about its moons? The icy crusts of Europa, Callisto, and Ganymede would melt and then instantly evaporate away. Any alien life hiding in Europa's ocean would briefly warm up, before being cooked out of existence. Next in line is Saturn, now frying in Venus's old position. Its average temperature jumps from bone-freezing cold to about 55 degrees Celsius (131 degrees Fahrenheit). Saturn's iconic rings? Say goodbye. The ice would melt, dust would scatter, and the entire ring system would erode under the Sun's radiation. You might get new magnetic patterns as Saturn's magnetic field clashes with the Sun's. Beautiful, but violent. Now we reach the Goldilocks zone, but Earth isn't here anymore. Instead, Uranus takes the lucky seat. Uranus's year shrinks from 84 years to just 1 Earth year. Sunlight warms the ice giant, possibly melting some of its atmospheric ice into liquid droplets. Does this make Uranus habitable? It has water, carbon-based molecules, and more energy. But it still has a crushing atmosphere and no solid surface. So sorry, Uranus will not become Earth 2.0. Maybe its moons would fare better. Neptune, normally a frozen storm world, now warms considerably. Its orbit shrinks from 165 years to just under 2 years. But more sunlight equals more energy equals even more violent storms. Neptune's already dangerous winds would become monstrous. Now for that big problem. For massive gas planets are crammed into tight orbits. As they swing around the Sun, their gravity would yank at each other chaotically. The entire system could spiral into instability, possibly tearing itself apart. Even if the system somehow survives, Earth definitely won't. Earth becomes the 5th planet. Earth gets bumped outward and ends up between Neptune and Venus. Too little sunlight reaches us. Our oceans freeze. Most life dies. Only a few deep ocean organisms might survive near thermal vents. We could even drift into Neptune's gravity and become its newest moon. Earth a moon. Imagine that. Even Venus, Mars, and Mercury freeze. Far from the Sun, these planets turn into icy wastelands. Venus's toxic atmosphere collapses into freezing acid ice. Mars becomes even colder. Mercury becomes a frozen rock. Definitely not ideal. Rearranging from smallest to largest. Okay, let's flip the order. Smallest near the Sun, biggest farthest away. Thermometer Mercury stays where it is. So far nothing changes. Mars moves inward. Mars warms up to about 32 degrees Celsius (90 degrees Fahrenheit. Similar to a hot summer on Earth. But solar winds would tear away its already thin atmosphere. Any water would boil away. No chance of making Mars habitable. Venus in the habitable zone. Still terrible. Venus enters the Goldilocks zone. But it stays an inferno. Its runaway greenhouse. Effect traps heat no matter what. Even if comets delivered water, it would evaporate instantly. Thumbs down for Venusian life. Ice cube Earth moves outward. Earth receives only half its normal sunlight. Global freezing begins again. Humanity would not survive this version of Earth. Blue circle Neptune becomes a night sky jewel. Neptune shifts closer to Earth and becomes the brightest object in the night sky after the Moon. Its gravity might even shield Earth from asteroids. Ring planet Saturn, Uranus, and Jupiter drift outward. Jupiter moves extremely far from the Sun, 6 times farther than before. Its year stretches from 12 Earth years to 165 Earth years. Out here, Jupiter becomes a cosmic slingshot. Its enormous gravity would grab asteroids and fling them toward the inner solar system. This could trigger a new era of heavy bombardment, like the one that shaped Earth billions of years ago. Not exactly comforting. Glow showing Europe-Africa why our current solar system works perfectly. Luckily, the planets are exactly where they need to be. Billions of years ago, when our solar system formed, gravity and orbital interactions pushed the planets into stable, balanced positions. Jupiter once drifted inward. Saturn, Uranus, and Neptune moved outward. Eventually, the system settled into the arrangement we have today. And thankfully, Earth ended up right in the Goldilocks zone. Because after all these what-ifs, one thing is clear. No other arrangement keeps Earth livable. Volcano, what's next? So what if Earth didn't move, but a massive supervolcano threatened to wipe us out? That's a whole other catastrophe. And a whole other what-if.